first let's discuss what the mapping operation is all about. Now the first step is map processing. Now we all know that HDFS splits the large input data, whatever your input is and however large it is, your HDFS splits it into smaller data blocks, which is controlled by a property called dfs.block.size. It splits your large input data into small blocks. You have to define the block size in this particular parameter, dfs.blocks.size. We all know that there are two values. By default it would be 64 MB. Alternatively, you can go ahead with 128 MB block size as well. Now, the data blocks are provided as an input to the map tasks. The blocks of data are given as inputs to the map task. This is what the job tracker gives to the task tracker, right? Now, the number of blocks for each map depends on a certain parameter, minimum split size. So this is a certain parameter where you will be able to specify what is the minimum number of blocks a particular map will handle. The same way, there's another property called MapRed.max.split.size, wherein you will be specifying the maximum number of splits. What is a split? Split is nothing but a block. Okay, so the maximum number of splits a particular map task would be handling. This is what is called map processing. Now you can assign 5 map tasks, 5 blocks to a map, or 10 blocks to a map. It is up to you. Moving to the spill. Now what's a spill? IO.spill. Now what does this parameter do? This parameter actually controls the threshold size of the buffer, post which the extra data is spilled. Okay. Now, when a particular buffer size reaches a threshold size which defaults to 80% or 0.80 of your memory, a default thread starts to spill the contents to the disk. When your data actually exceeds a certain threshold, the extra data is starts to get spilled onto the disk, meaning which it is outside your map's capacity. It gets written to your disk. Okay. Now while the spill takes place, map continues to write data to the buffer unless and until it is full. Spills are written in a round robin fashion to the directories specified by MapRed local directory property. Now this is one property where you would be assigning the path where all your spills would be written to. A new spill file is created each time the memory buffer reaches to spill threshold. Now this is something called as spill. That is, whenever a particular memory is exceeded, by default spill memory is specified, which is 80% of the available memory. Now whenever your memory is your data is exceeded, what happens is that the extra data is written to the disk. We call it as spill. And the path where all your spills, this is for one particular map. You have 1,000 maps and all 1,000 maps can kind of spill data. So you specify in general a particular directory where all your spill files are written into. Now let's see what sort is. Basically, sorting is a function, right? It's an algorithm. Now all algorithms are basically performed in memory. That is, if RAM is utilized, right? So an in-memory sort is performed on the key. When we are talking about MapReduce, we basically are talking about key value pairs, right? So an in-memory sort is performed based on the key. Sorted output is provided to the combiner function in case you use it. Okay. Now the output of the sort is given as an input to either the combiner if you use it. If you don't use a combiner or a grouper, it would be the input with the reducer. Now this is sorting. So first step is you define how many blocks a mapper should be using, and spill is an optional thing. A mapper can spill data or it need not spill data. Next is sorting. So sorting happens based on the key value pair, basically on the key. Okay. And once it is sorted, sorting happens in memory, guys. Since it is a part of processing, data processing, RAM is used. So sorting happens in memory and the output is thrown out either to your combiner or the grouper if you use it, or it goes to the reducer. Now the final step, the last but penultimate step is merging. Now before the map task is finished, okay, before the map task is finished, the spill files which have been accumulated, okay, are merged into a single partitioned and a sorted output file. You have many maps, but certain maps have spilled data. Now what do you do with the spilled data? Spilled data is also useful data which the map could not handle because of the size which you have specified. Now what happens to the spilled data? The output of a map is actually kind of sorted in memory and sent out. Fine, it's all good. Now what happens to the spilled data? Now there's some step called as merging. What merging does actually is that it accumulates all your sorted spilled data. Okay, it accumulates all your spilled data and it merges out, and it is all and the merged output is basically a single file. Okay, basically a single file, and you can actually configure how many spills can be combined to a single file. Not necessarily if there are 1000 maps and all the 1000 are spilled data, you cannot combine all the 1000 spills to a single file. Rather, it's ideal for you to specify in a property file how many spills should be merged into a single file. Now this property is controlled by io.sort.factor. Basically if it's 10, meaning which 10 spilled files would be combined, would be merged and then sent out as an input. Anyway, by default the value is 10. Okay, so basically 10 spills are taken into a single file and then it is sent out as an output of the map. Okay, it acts as a map even though it is not. Now this is merging. Now post this we get into compression. Now this is again optional. The map output can be compressed before writing to the disk for faster disk writing. Now the final step is compression. This is again optional, guys. We all have properties for this. If the default being either true or false. Okay, in performance tweaking we'll be discussing these factors in detail, but it's very much important for us to understand what these things are. Now the output of a map can be compressed before being written to the disk. 3 advantages. First one is faster disk writing happens. Second advantage, when you compress files, it utilizes less disk space. Okay, third advantage is that when you lessen the disk space and when the size of a file is less, the amount of data you transfer to the reducer is also less. Okay. Now this property, that whether you want to use compression or not, is the name of the property is mapred.compress.map.output. Okay, which by default will either have true or false. And let me tell you, by default it is false. You don't compress data. If you want it, you can go ahead and change the property file. You can change this particular property to true. Okay, so these are the steps which actually happen in the map. Basically we just say, okay, this is map and this is reduce, but these are the steps. One is you first describe how many blocks the mapper should take, and then in case spill happens, we merge the extra spills. How many spills do you merge at one shot? 10 spills, but you can increase it. Next, for those unspilled data, there's a sorting happening in terms of key. Okay, once the sorting is done in terms of key, which happens basically in memory, we send it to the reducer as an input. And before we send the output of the map to the reducer as an input, you can either compress it or you need not compress it. It is up to you. Okay. So these are the steps which internally happen in a map. Now let's discuss what happens in a reduce. So let's get into reduce operations. Now what are the internal tasks in reduce operation? The first one is copying. Okay. Now what is copying here? Each map task's output was given to the reducer as input. Now the output of each and every map task is copied to the corresponding reducer. Now when I say that corresponding reducer, you should not quickly ask me, how does a map and a reducer, I mean what is corresponding, how do they know that which corresponds to which? No. That you only need to be bothered about 3 things. You have to write your map class, you have to write your grouper class if any, and third is your reducer class. You really don't need to bother how stuff works because your MapReduce framework does this logic for you. Okay. Now each map task's output for the corresponding reducer is copied as soon as the map tasks complete. Map tasks complete. Now there's a difference. It's not map task but map tasks. So all the tasks of the maps should be complete for this to happen. So once the output is copied to the reducer's end. The reduce task has a small number of copier threads so that it can actually fetch map outputs in parallel. So the default value is 5 threads, but this can be changed by setting the mapred.reduce.parallel.copies. So basically, we are dealing about data copying from the output of map to the input of the reducer. Okay. Basically, they have every reducer will have small threads which will actually copy the output in parallel. Now there is a property called mapred.reduce.parallel.copy where you can define the number, the default being 5. Okay, so 5 threads run in parallel, which will enable you to copy the output of a map in parallel to your reducer. Once this copy step is done, let's see what sort again here. See, sorting was already done in the mapper phase. Now what is this? This phase should actually be called as the merge phase. The reason being, the sorting is actually done at the map side already. Okay, but somehow we refer it to sort phase. This phase starts when all the maps have been completed and their output has been copied. Post the completion of copy step, we go ahead with a merging step. Okay. Now the final step is your reducer. During the reduce phase, the reduce function is called for each key in the sorted out. The output of this phase is written directly to the output file system. Now what is output file system in our case? It's HD, right? So every time there is a reduce function, every time there is a key, a reduce function is invoked in the sorted output. And the output of the output of the whole reduce function is actually written directly to your HDFS. Okay, so there are actually A, B, C, D, E, F, G, H. So 1, 2, 3, 4, 5, 6, 7, 8. 8 steps happen internally when you say just MapReduce.